This is a reaction known as the Williamson Ether synthesis, and it's a very famous named reaction. It's a very reliable and relatively simple way of creating symmetric or non-symmetric ethers. Usually it's used for non-symmetric ethers because there's what people consider either simpler or less kind of involved ways of creating symmetric ethers. But you can create ethers very readily with this reaction. And what you need is you need an alkoxide ion, and then you need an alkyl halide. And this contacts using an alkyl bromide. And I don't know why, but I just really like this reaction. Again, probably for its simplicity. And it uses just simple concept you already know in Organic Chemistry 1, which is an SN2 style nucleophilic attack. So the alkoxide in this case functions as our nucleophile. It's got a ton of electrons, and it's a good electrophile, or I'm sorry, a good nucleophile. And we have a nice primary substrate. You need the primary substrate. Technically, this can work at some secondary substrates. But remember, secondary substrates are really tough for SN2. You're going to have a lot of competition with E2, and it's going to slightly favor E2 based on a lot of the literature. What's going to happen simply is we come in, we just tack that carbon nucleophilically and kick off our bromine. And now we have our ether. Now in reality, this is likely some sort of counter ion with it, so it's maybe a sodium methoxide. Or what you can do is you can create this in situ. You simply take an alcohol, like this. So you dehydrate it, say with sodium hydride, which will then remove your alcohol, because in sodium hydride, the sodium is a positive charge, the hydrogen has the negative charge. It's going to steal your proton, kick those electrons up onto our oxygen. We're going to release H2 gas, which is going to give us our alkoxide. And then we do this step here again, and we would, tack our our alkyl bromide, and we create our ether yet again. Now, like I said, this relies on SN2 chemistry. So if there is stereochemistry here, there will be stereochemical inversion. However, remember, SN2 does have a tough time at secondary positions where you would see stereochemistry. In a primary position, there isn't stereochemistry because there's two hydrogens right here. So that's not something you really see. And also, you got to remember that something like alkoxides make really good bases. So if you start messing with things, it's going to start favoring E2 because it's a good base. You also need to be selective with your solvent choice. This is a really good, simple method of making ethers that uses fundamental Organic Chemistry 1 organic substitution reactions. If you want more organic chemistry learning, hit that follow button.